Hello, welcome back. This is a video for Math 8. This is Unit 7, and this is Section 5. We're going to be talking about rotations, more like brotations. And what we want to do today is we want to identify the image of a figure after a given rotation, analyze a graph to determine the angle and direction of a rotation of a figure. So before we get really into like the technicalities of what a rotation is, remember that a rotation is a turn, okay? And I like to think of the word clock because the hands of a clock turn around a center of rotation. Now let's go up here and let me show you a visual of what this means. Okay, so if we take a look at this picture here, notice that this is a picture of my face. And I have this dot here. And what I'm going to do is I'm going to rotate my picture around this dot here. All right, so as I do that, I'm just going to rotate my face. Now, what I want you to see here is that my face goes around my center of rotation, okay? And that my orientation changes as we move around. Okay, my chin is always pointed towards my center of rotation. And I'm going to come in here and write that this is the center of rotation. Okay, and I want you to notice how my face changes as we move around the center, okay? How the orientation of my face changes, okay? And that's just what happens, okay, when we do a rotation. So now let's take this same idea of what I'm doing here and apply it to the math that we're currently doing. All right, so we talked about the center of rotation, and so all rotations are centered around a point called a center of rotation. And so what we have here is we have point C is the center of rotation, okay? And we're rotating point A. So point C is the center. And we're rotating point A around point C, okay? And we're doing this turn to go from that point to that point, okay? So notice that we always have a center and we always have to identify what that is, okay? Now let's take a look at the next one, all right? And so this is the same idea, except for instead of just turning a point, we're actually turning an entire triangle, okay? So triangle BCD is rotated around point P, okay? So here's point P. So let's label our center, okay? That's my center of rotation. And we're taking each of these points and rotating each of these points by the same angle. So let's write that each point is rotated by the same angle. Okay, in this case, this is a 90-degree turn. And we talked about that when we did rotations on the other one. But let's talk a little bit more about revolutions and degrees. Okay, so we have revolutions. So rotating a figure 360 degrees, and that's going to be one full circle, okay, will result in one revolution. So one revolution around a center will bring the point back onto itself, okay? So a complete circle will be formed if you rotate, if you follow the path of a vertex that is rotated 360 degrees in either direction, okay? And so if I were to take this point here that we have, all right, it would rotate, over to here, over to here, over to here, and back around, and then you create a circle, okay? And that's what a revolution means, okay? Now, we can either go counterclockwise or we can go clockwise. It doesn't matter, okay? So clockwise and counterclockwise rotations. So going in this direction here is counterclockwise, all right? And you have to think about how a clock hands turn. Okay, and then if I were to turn it the other way, the way that the hands of a clock go, I would go this way, and this would be clockwise. Okay, and so those are important things to remember. Now, when we talk about this, if we talk about a clockwise rotation, if we're talking about degrees and how much we turn these, counterclockwise has a positive degree rotation. Okay. Now, if we're talking about clockwise, that would have a negative degree rotation. Okay, and so let's take a look at the next page so we can talk about what degrees mean when we talk about rotations. All right, so when we talk about angles of rotation, we can think about any number of degrees that we want this to do. We're going to stick with multiples of 90 degrees. So we have a 90-degree rotation, we have a 180-degree rotation, 270 degrees, and then 360-degree rotation, okay? A 90-degree rotation is just a quarter revolution, okay? 180 degrees is a half revolution. 270 degrees is 3/4 of a revolution, and then 360 degrees would just bring it back onto itself, and that would be a full revolution, okay? So notice that each of these rotations, when I go from one point to the next, gives me that angle measure. So I want to do a 90-degree rotation here. And so I'm just going to look at point L here. That's kind of well, let's not look at point L. Let's look at point J, okay? And when I look at this to go from point J to point M, that's a 90-degree rotation because the angle that is made with my center is a 90-degree angle, okay? Now, when I do a 180-degree rotation, if I'm going from point J and rotating this all the way to point Q, then the angle that's created with that in the center, those 2 points, is 180 degrees, all right? Same thing if I were to do a 270-degree rotation. That means I would go all the way through to point T, and that angle measured, I have a 90-degree angle here, 90-degree angle here, and 90 degrees around my center. That would give me 270 degrees. And then finally, if we talk about a 360 degrees rotation, that is a full revolution that brings it back onto itself, okay? Now, each of these points are doing the same thing. If I'm going from L to P, this is a 90-degree rotation. Doesn't really look like it, but if you look at the angle that's created between those 2 points, that's 90 degrees, okay? And that would be the same thing with all of them, okay? I don't want to draw all those, but the angle of rotation is formed, okay, by the vertex of the preimage, center of rotation, and the corresponding vertex of the image. So let's just take a look at from point A to A prime, okay, A to A prime, this rotation, okay? And we talked about the center of rotation is the origin here, and the angle measure that's created is a 45-degree angle according to this, okay? And that's what we want to look at. So we want to go from one point to the next, connect those points with the center of rotation, and that's going to give you your angle of rotation. Okay, so 180-degree rotations, whether I do a 180-degree rotation either clockwise or counterclockwise isn't going to matter, all right? So if I go from, say, point C to C prime, I can go clockwise or counterclockwise and go in the positive direction, all right? Then that will give, connecting these points here is going to give me 180 degrees, okay? Now, if I go the other way and I go in the negative direction, it'll also bring me back on to my same point C prime over here and will give me the same thing, 180 degrees, okay? This was counterclockwise, clockwise, and this is counterclockwise, all right? And that's what we're doing. So hopefully, this isn't too awful for you. We'll talk more about rules and how we get, go from one point to the next and what that looks like using these various, degreed rotations. So hope you're having a good day. We'll talk to you soon. See you later. Bye.